page 446. You're going to be doing the problems 30, 32, 33, 34, and on that you're going to name all the major parts and graph them. Then in addition to that, I want you to write the definition of a hyperbola 5 times. That's 5 easy points. No math involved. Write the definition 5 times. I also want you to tell me an application of a hyperbola. And I'll give you some examples once we get going. Okay, so the definition of a hyperbola is a set of points in a plane such that the absolute value of the difference between 2 points, which are called the foci, is constant. The standard form of a hyperbola is this. Notice it's in subtraction. Didn't you guys just get finished doing the ellipse? And you saw it was in addition. So it's basically the same. There's going to be 4 major parts: the center, the vertices, the foci, and the asymptotes. So basically, each of your problems that you're going to be doing up here are going to be worth 5 points apiece. Because you're going to tell me, it's going to have to be in correct standard form, in order to tell me the center, the vertices, the foci, the asymptotes, and then graph it. And then you're going to get that 5 points for writing the definition, and then you're going to get an application that you get to write down as well. Okay, is everybody ready, or need to wait?
I'm not done yet.
Okay, and always just let me know. I won't start examples until I got you on my same page. Now, did you guys have assignments to turn in?
We turned them in yesterday.
Okay.
Most of them.
Was this one that was turned in?
Kate was calling.
Okay. Anybody else have any? And from here on, I'll be grading your papers. And usually I'm one of those that likes to return them the next day, so you'll be getting them back the next day with comments on them. Another thing I've added is I have a big marker board in my classroom that always has the week's assignments on it. And I knew I couldn't do that here because you guys don't have as much board space as I do. So I made a little one that if you ever want to see what your assignment's going to be for the week, it's up here. The 20th, the 21st, the 22nd, the 23rd, and 24th. I've got them all written up there. So that's always something that you can look at. Which you notice what's going to happen next Friday. Test. We're going to review the day before. We're going to do chapter review here, which is problems from the exercise that reviews everything for you. So pretty much that's our guidelines there. Okay, you guys ready to go?
How do you spell the last word? I can't quite read it.
Asymptotes. A-S-Y-M-P-T-O-T-E-S. Now this one, you don't need to write down. Because I'm going to do a simplified version first, just so you get the hang of how to do the hyperbola. Now, I already said what the definition is: set of points in a plane such that the absolute value of the difference between 2 points is constant, and that's the foci is the 2 points you're concerned with. But an application of a hyperbola. Anybody sonic boom? When the plane goes over and we get their sound waves, that's a hyperbola. There's the sound waves below the plane and above the plane. But what we hear is what's below the plane. Another application is projectiles. When people are leaving the orbit of the Earth, you have to get a certain projectile, and that ends up being a hyperbola. Another one you might have in your, and I'm not a good drawer, I'll tell you that right now, in your homes. A table lamp. You have light above the shade and light below the shade, and those are hyperbolas. So I've given you 3 applications. Remember, in your assignment you've got to name one. So I've given you 3 you have to choose from. Okay, now first thing we're going to do is we're going to identify the center, which it's the same way that you did with the ellipse. Let's see, Aaron, could you tell me what the center of this would be?
Just like the values that we use for it.
What would this start from? Just like your ellipse, so I'll give you a hint. X minus That's what I want to hear. Center is 0, 0. So remember when you did your ellipse, didn't you change both the signs that were in with the x's? And isn't it understood that x minus 0 is x? So you don't really have to write that. That's why it's not. It's understood. Okay? Now, we're ready for the vertices. The vertices all depend upon which variable comes first. Which variable's coming first in this problem? X. That's the one that's going to do the changing. And what it's going to change by is the square root of this value. So what's the square root of 25? And that would be plus or minus, right? So you're going to add 5 to the x value of the center, since that's the one that came first. And you're going to subtract 5 from that x value of that center. So those are the vertices. The vertices are always going to be the variable that comes first. You square root it. Yes?
Can't order change in problems though? Like,
Yes. You're going to see an example where the y comes first, so it'll be different.
like, I mean, like, can the y convert in this problem and change it completely?
No. The subtraction is the key.
Like,
The subtraction sign has to stay. The second one has to follow the subtraction sign.
like what kind, oh, okay, never mind.
You see the difference? It's a
Yeah.
difference in the ellipse. Okay, next is the foci. To get the foci, what did you do on the ellipse to get the foci? I'm giving you a hint.
You added,
You subtracted them to get your foci on the ellipse. What do you think you're going to have to do on the hyperbola?
subtract.
Add them. You do the opposite of what's here. Okay, so 25 plus 4 is, so it's going to be a plus or minus 29, is going to be added to your center again, the x value. So 0 plus the square root of 29, and 0 minus the square root of 29. And you guys know what asymptotes are, right? You've already done that this year, haven't you?
No, I don't think so.
Asymptotes are where you have a line and you get close to it, but you never cross or touch it. You may have touched on it a little. This we aren't so concerned with it, it's just an aid in graphing. Okay, now to get an asymptote is a line. What's an equation of a line? Anybody tell me what an equation of a line is? Y equals mx plus b, right? No line. So what's important about when you graph lines? Don't you have to know the slope? And what's slope? Rise over, so that means you need y over x, which is very important. So this is going to be a y equals plus or minus x. You don't have to worry about the b, you aren't going to have one. All you're going to have is that slope. So slope is rise over run. So what's the square root of the y value? Over what's the square root of the x value? So that's going to be the slope of our asymptotes. And slope is always rise over run, so that's y over x. So that's always going to be that case. Now, to graph that, you find the center, and I'm going to show you a trick for graphing. You don't really have to know any of this stuff to graph it. But you can use that to check to make sure you haven't made any mistakes. So our center is 0, 0. And you probably did this with your ellipse. In the x, what am I going to go? How much in each direction? 5. In the y, I'm going to go how much in each direction? 2. Now before with an ellipse, you drew the ellipse, right? The elliptical shape. Now you're going to draw an imaginary rectangle. So it's only going to be a dotted rectangle because it's really not part of your graph. It's used to get the asymptotes without much work. So now, what are diagonals of a rectangle? Geometry, right? You connect non-adjacent vertices. That's the diagonal. So that's what I'm going to do.
You said not to write this, right?
No. I'm going to give you the one I want you to write here in just a minute. I want you to absorb this one. If you're writing it, it's fine. Some people write very quickly and they can write down everything I put up there. But there's certain things I'll tell you what to write. Now, my vertices are at 5, 0. Or here's another way to remember it. Which variable came first? That means my hyperbolas are gonna go on the x-axis on each side, getting close to those asymptotes without crossing them. And those dotted lines are the asymptotes. Asymptotes are always dotted lines, because you get close to them without touching them. So the hyperbola, and let me use a different color, is really this part right here. Now, we're going to use that to check. What did we say the vertices were?
5, 0, negative
Did
5.
they end up being the starting point of our hyperbolas?
Mm-hmm.
Okay. Foci, what's the square root of 29 approximately? 5 something? That means it's somewhere in here and somewhere in here. Which foci are always found inside the hyperbolas. There's another check. We're checking everything as we're going. Now, what did we say the slope was?
2, 5.
So did we go up 2 and over 5 to get that line? Did we go down 2 and over 5 to get that line? Yeah, see? So you can do all that without even using it, by simply using the little trick of the rectangle. Okay, now, this next example I want written down. And I'll try to go down the row and see if you guys can help me out. And you guys will have to warn me about time. I'm used to my clocks. So I know every time I get out of school in Riverton. So you guys are on a different bell system than me. Okay, what's wrong? Is it in standard form? What do I need to do?
Divide them into 4.
And I get, you're Robert, right? Okay, you gotta divide by 4. Does everybody agree we gotta divide by 4? Why?
Because you want the constant to be 1.
You want it to equal 1, so we're gonna divide by 4. And notice I put the 1 there. That just makes it easier when I get to the problem. Okay, do you have questions about that yet? So, got to get it equal to 1, just like you did with the ellipse. The only difference is the hyperbola is in subtraction, where your ellipse was in addition. So that's how we distinguish between the two. Okay, next step. What do we have to identify? Center. And you got to be careful, because how do you write a point? X comma Y, right? Doesn't X always come first? So you got to pay attention to which one is X and which one's Y. Now to get your center, when you did your ellipse and when we just did it, don't you change both of them? I always say change, change, because in the parabola you go change, keep. You know, there's some tricks for things. So I'm going to change my X so it's going to be a positive 1. I'm going to change my Y so it's going to be a negative 2. Does everybody understand how we get the center? It's just like when you did the circles and the ellipse. You change both X and Y. Now, vertices. Here's where we got to start thinking. Which variable came first?
Y.
That's the one that's changing. The Y is going to change in the vertices and in the foci. So the Y came first, so you take, what's the square root of 4?
2. Plus or minus.
So plus or minus 2 is going to be added to the Y value. Okay, what's the Y value?
Negative 2.
Negative 2. So let's first, so what's a negative 2 plus 2?
0.
0. So he's got the first one. Let's see. Nicholas. What would be a negative 2 minus 2?
It would be -4.
That would be correct.
We always change the value that we're using.
Yes. You always take that center value and you change it by that amount. Add it, subtract it.
Like since the y is listed first, we use the y value.
That's correct. That's the key thing. Now, isn't that different from the ellipse? Didn't you have a major and a minor axis? But didn't it go by which one was larger? See, this one's totally different. Hyperbola is what comes first. Okay, foci. What do I do to get the foci? Add the two, A and B together. So what's 4 plus 1?
5.
I'll write that down so you remember that's what we do. So it's going to be plus or minus square root of 5. Let's see, Spencer. So I got to add it to the y value of my center. So what will my first one be? Yeah,
Plus.
plus the square root of 5, because what's the other one gonna be?
Minus.
Minus. So he took care of both of them for us. You add it, you subtract it. Add it, subtract it. Okay, now, the asymptotes. An asymptote is in a line, which is a y equals x, right? What's our y this time? It's not y minus 0, it's y plus 2. Equals plus or minus, what's my x this time? X minus 1. Now, how do I get the part, the slope? Let's see, Tatum, how do I get the slope?
So y equals mx.
So we need the m, right?
Yeah.
And then that rise over run. So which one's the y value?
The 4.
So square root of 4. What's the x value?
The square root of 1.
So we end up with
2 over
2. And now we're ready to sketch a picture of it. So to sketch a picture of it, and it's just a sketch. If you want to get graph paper, you can. I always just do a T-graph. Okay, so I first find my center at 1, negative 2. So 1, negative 2 is to the right 1, down 2. Now, what was my trick? You take the square root of each of them, and then you're going to make a rectangle around it, right? So what's the square root of 4?
2.
So you're going to go 2, up and down, because it's a y. 1, 2, and 1, 2. My x, what's the square root of 1?
1.
So 1 to the left and to the
Right.
right. Always from your center. Now, I guess I'm going to use the red now, because my black is going to be hard to tell. I need to move, you bring more marker pens, it looks like. So all I did was connect the dots, basically, and make it in the shape of a rectangle. This is not the hyperbola. This is just a way to get the graph of the hyperbola so that you can use this stuff to check your answer. Okay, so we're going to draw our diagonals. And all those red dash marks. And if you want to use ink pens to do your asymptotes in your rectangle, that might help. So that way you can tell it's different from your hyperbola. Now, which variable came first?
Y.
So that means what?
Y's changed. So
It's
vertical.
It's going to be up and down, right? Okay, so it's going to be from. So there's the first hyperbola. There's the next one. Now, what could we do if we want to check it? Go through the stuff. Is my center at 1, negative? We know that one is. 1, 0, is that where I started?
Yes.
1, negative 4, is that where I started the other one?
Mm-hmm.
You can check to see if the foci is inside the hyperbolas by going, what's a negative 2 plus the square root of 5? Square root of 5 is about 2.2. So added to a negative 2 would be about 0.2. So it would be somewhere in here. So is that inside? Same thing here, negative 2 minus 2.25 would be about negative 4 something. So it'd be somewhere in here. So we're good there. Now, what about that slope? What's our slope? So from the center, can you rise 2 and run 1? And it looks like we did. And go down 2 and over 1. So we're good.
I'm really confused.
Question?
I just don't understand how we did,
How we did the graph of it?
yeah.
We're going to do another one. Okay, and then I can help you individually. Everybody got that assignment written down up there? Now, you guys have been completing the square, have you not? So we're going to do one that you're going to have to complete the square with. Whoop. Okay. So what do we do when we complete the square? You got to group your x's together, group your y's together, get your constant on the other side. Ellipse, circle, you've done it. So this x is one of its kind. You don't have any parts with it. My y's, don't I have two of them? So I'm gonna factor out that 4, because when you complete the square, doesn't the coefficient have to be 1? Okay, so we're gonna have y squared. 8 divided by 4 is 2. And a negative divided by negative is a positive. And I didn't mention them. When you hand your assignment in on Monday, you'll hand it in, because I grade them. I don't like people grading papers. You'll hand them in, but before you hand them in, if you have a question, put it on the board before it come in, and I can take care of at least, well, we only have a few problems, but I could do at least one if you have one that you have a question on. Does everybody understand? So we take care of that before we hand them in. Okay, so this one's okay, but what do I do to complete the square here? Because you can't have, if you have 2 or more, you gotta complete the square. So what's half of 2? Squared is,
1.
so I added 1 here. Does everybody agree we add 1? But really, didn't we add a negative 4? So what I gotta do to the other side?
Subtract 4.
Subtract 4. You gotta do the exact same thing. Okay, now we're ready to go. X squared minus 4. How does this factor?
Y squared. Or
Y plus 1 quantity squared equals 1. Okay, now, this one's unusual. It's already equal to 1, isn't it? But you can't have a constant in front. So I need to do something. Is this not the same?